Welcome to Operation Heritage Shield. The scope of this exploration is aimed at benchmarking Sicilian settlement and ancient Greek architectural stronghold in the Mediterranean. I'm architect, secretary, and engineer Salvatore Polverino, and I will dissect for you its historical significance, deploying a sensing solution for its preservation. Today, I have the distinct honor of discussing the cornerstone of architectural excellence in Italy, the Ordine Professionale degli Architetti. This revered institution operating under royal decree, information analysis within the broad spectrum of engineering, especially pertinent to domains like electronic warfare, data science, and communications, embodies the comprehensive process of scrutinizing, manipulating, and decoding data to uncover significant insights, tendencies, and conclusions. Here is a closer look at the key components involved in this extensive protest. Selinunte stands as a key strategic site in cultural defense along the southern Sicilian coast, originating as a Greek colony, 7th century BC. The site speaks volumes as a vital asset in understanding Mediterranean historical architectures and cultures with a preserved heritage park. The inquiry, where are we in times of peace, becomes profoundly relevant, underscoring the contrast between historical conflicts and contemporary serenity in Sicily. This question not only reflects on the physical remnants of warfare, but also invites a deeper contemplation of their place in today's peaceful times. The Battle of Monte Cassino, a pivotal ground engagement in World War II, highlighted the limits and capabilities of wartime technology. While the battles was defined by traditional infantry and artillery combat, the use of radar and radio communications played a strategic, albeit limited role by bulkiness, on-field signal interception. Thus, the essence of EW through techniques like signal jamming and interception transcends its immediate statistical value, reflecting broader themes of digital age defense with a long-term dynamic interplay between innovation and preservation. In this case, both active and passive solutions supported by LiDAR product. Sentinel-1 operates on interferometric synthetic aperture radar or INSAR technology, providing continuous Earth imagery regardless of daylight on weather conditions. It does not utilize spectral bands in the traditional optical sensing manner, rather performing with radio waves. Cloud penetration and data collection under any weather conditions, making it ideal for emergency monitoring. Landsat 8 mission was preferred rather than Sentinel-2 due to its historical continuity, providing a continuous record of Earth's surface since 1972. Its radiometric resolution operates with a 12-bit surface reflectance rather than Sentinel-2's 10-bit resolution. Phase unwrapping place, transforming the cyclic phase information omega wrapped from dual SAR imagery into a continuous phase domain omega continuous. Left below the visual configuration of stacking the shortwave green band lambda 3 with C-band radar data. This integrated approach also combined the horizontal W polarization for signal transmission and reception with the diffusion of optical and radar imaging. Now the scrutiny based on overlapping fusions. Radar's data encapsulates a demographic range from DEM 1 to 13 one by one, delineating distinct elevation contours essential for signal integrity. Principal components analysis simplified the complexity of dim data derived from interferometry. 3D scale models detailed reconnaissance of landscapes, sunlight across the terrain, gradients for erosion patterns, and inclination with surface runoff and soil retention. Multispectral band statistics across Landsat bands, cloud removal and top of atmosphere correction were indeed performed beforehand. 13 dim sites were priorly analyzed for the site selection jargon based. With a resulting mosaic for this short-term decision-making analysis via differentiated analysis, ending with DNDBI, CSAR, overlapping ULIT area of interest, DLST, and INSAR 456. Now the percentiles from the before mentioned differentiated indexes, corresponding cross-tab logarithmic scales, statistical analysis of ecological data for each dim site, and kappa accuracy for each Landsat 89 OLI TIRS data, and the structural characteristics computed in the discipline of image electric sensing. In example, mean contrast, density features, number and length of edges, uniformity, and connectivity metrics. For adaptive design. Magnetic azimuthal topographic delimitation has accommodated landscape changes, ensuring long-term viability and landscape architecture resilience. The creation of Fresnel decibel level maps, heat map, derived from the median values with the impacts of the Fresnel zone. By focusing on the median values of path loss and signal to noise ratios across several mapping and sub-scenarios, ensuring that the heat map reflects the most common signal conditions. High path loss and signal to noise ratios evaluated transmissions data crucial for network performance across 13 antennas plus 1 in the water domain. A Selinunte area park has been entirely benchmarked through decibel level analysis compared to elevation and to dissect terrain's impact on signal propagation. Leading to the Malophorus temples in the west, the EW analysis served to this dual purpose. Firstly, it enhanced our communication infrastructure, ensuring the protection of the mysteries of Selinunte, from the majestic Acropolis to the enigmatic Eastern temples, without compromising the archaeological value in defense sector. Ordine Architetti Napoli can ensure clear, uninterrupted communication channels across heritage sites. As for this case study, Selinunte Park, AW approach can be interpreted in the Vitruvian principles of architecture and informed by the dromological theory of Paul Virilio. We advocate for a dynamic, responsive planning that transcends traditional preservation and evaluation methods in heritage. The sensor fusion of INSAR active radar with GLCM SNR path loss ground analysis, leveraging a comprehensive array of aeronautics ranging from G-force, fuel load, detected temperature to electronic emission profiles and truss infrared signatures. As we concluded this journey, our heartfelt appreciation extends to the Naples organization in collaboration with the University of Antalya Amla Pasa with esteemed professors Ahmadnia and Raha Bariaj at the helm. Special thanks are also due to President Paolo Pisciotta, Architect Antonio Coppola, President Lorenzo Capobianco, and Professor Leonardo Di Mauro for their invaluable contributions and leadership. We appreciate your participation in this presentation. Thank you very much, and see you at the conference. Goodbye.